Okay, so I have them wired up to run on high. Straight to high, no switch. That's what I get on high. Then I'll set it to low. I think the capacitors in these are 2.6 microfarad to 3 microfarad, so a 2.8 would work fine in this. And it has to be above 285 vac, so you'd probably want 330 vac, or 240 vac is perfectly fine, so that way if anything happens where the motor gets stalled, it won't burn out. So runs pretty good. It's wired straight to high. If you don't have a switch or you don't want to buy a switch, you can do this. I figured out the wire diagram for a toggle switch on this, so now I'll be able to use it. And I think I can make it run on the what is it? I'll be able to run the window fans too like this, so. Then I'll get the other one set up. Here's my sketchy wiring, but this should be low. Power factor 8. There's the vac. It runs pretty good, but let's see what the vac is starting up. But it's running good how I have it set up for low. So my wire diagram is correct. So if you want it on low, you can wire it this way. So all you have to do is, for low, is 2 of these wires have to be wired together, but it's separate from power. So power would go to the capacitor, one terminal of the capacitor, and then the other power would go to one wire in the motor, but you have to figure out which wire. So the wires I have marked as 3, and then the wire 5, which is right there, goes to the capacitor. 5 goes to this terminal right there. That terminal. 4 is the other one. So 5 and 6 are connected together. Power goes to 6, which goes to that terminal on capacitor, which goes to 5, and 5 and 3 only have continuity with each other. I think those are the run windings. Not 100% sure, but I'm guessing, because it's always common. And then that one, since it's the run one, would get hooked up with the start, or no, since it's the that's the run, it would go complete the circuit by doing series. I always thought these were more complicated. They're not. They're really not. For series, it would go, instead of creating 2 paths where it could go through, it just creates one long one, so that way it would run slower. And all it will do is it will go through 3 to 1, 1, 2, and 4. When you disconnect, you have to disconnect the capacitor to get it. 1, 2, and 4 are connected together. So 1 and 2 will give you the same reading as you get from 3 and 5. But to figure out which one is which, you will try 4 to 1. That'll give you a reading, and I forget what mine was. 4 to 1 is going to be higher than 4 to 2. And so 4 to 1, and you'll figure out 4 to 1 would be like the higher reading. 4 to 2 would be the lower reading. So you have 5 and 3, which are completely, it won't go, those are the only 2 wires that will go together. 3 won't go to anything else, 5 won't go to anything else. So you'll connect the 3 And I don't know if they're interchangeable, if it'll run in reverse. You can try it. I don't think they are. But, I don't know. Whichever one runs correctly and draws the right amount will be 3. And then you'll connect the other one to the capacitor. It shouldn't matter. I don't think it will, but... And then you'll connect 3 to 1. One's the higher ohm reading with 4. 4 is the other side of the capacitor right there. And then 2, which is the lower one, will get connected to power. And then you'll obviously have power to the capacitor. For high, what it does is... What is it? I forget what my power was. I had it written down here. Sorry for the long video, but power is 3 and 2. So 3 and 2 would be connected together to power. And then 1 and 6 would be connected together to power. That's how you get high. And it's a parallel because the way it works is between 3 and 2, you would go through, I think it's like 5 would go to 3, and then 1 would go to 2, but it also goes to 4, but you're just looking through 1 and 2, because once you get that, it gets complicated. And then when you connect it to, that's for low, and then when you connect it to high, it goes to 3 and 2, so 3 goes to 5, which goes to power, but 1 will go, I think it's, yeah, 1 will go to 6, which is power, and that'll create, and since 6 goes to 5, it'll create a little circuit there, and 3 and 2 are connected to 4, so that'll create a little circuit there, and that's the parallel one. That's how you get high. It's kind of weird, but it was weird for me, but once I figured it out, it's the same as that. It's the same as those, I'm pretty sure the what is it? I'm pretty sure that the Emerson window fans are the same. But this only works on the capacitor rollabout fans. There is a shaded pole one, which is really easy. It's just a common one winding and other winding. The higher, the higher ohm winding would be your low speed winding, and the lower ohm winding would be high. It's really easy. This is the only hard part because they add a capacitor to add more efficiency. Starts better and everything. But it's kind of cool. It took me a while to figure it out, but I remember looking at my old drawing, I had to figure out from the original switch. This is the 451. I think the 450 is the same. The 451 and 450 are the same. And then I made a little thing about the switch. So this is the top. This is the logo. They don't have a logo on the bottom. So it's like this would be the top to the logo, and that's the bottom. But it's out that way. You can look at it like that. So from A, since these are two separate circuits, remember that the A and B are two separate circuits. B doesn't get powered in the second position. A would go to 4 and 3. 4 and 3 are basically the same thing, but I didn't want to mix them up because this is connected. But I just did it that way. It could be 1, it doesn't matter. 4 and 3, 3 is the bottom, 4 is the top. It doesn't really matter. They're both going to get powered anyways. And then the 4 and 3 get powered. 1 gets powered. 1's on the top. So that would be your high, since that's parallel, because they're both getting powered. B is a second that's on the bottom, and that powers 2, just separately. Position 2, you switch it. This is low. So A is still powering 1, but B doesn't get powered by anything. Usually that's where your common is, that always stays powered. So the B's disconnected, that screw is disconnected, but if you had a power going to it, it would still, and you had another wire, it would just go straight to that wire. 4 and 3, that's just one thing, and then 2 gets powered together. That's how they close the loop. Since you need to like, you have the I'm trying to figure out a way. Let's see. I know this is a long video, but it's kind of supposed to be informational. So, let me pause. So I know this is a bad drawing, but these are 2 motor windings. Just imagine that. So you have one to here, and it has to complete the circuit there. So for this one, to create high, this is obviously not how you do it, but you connect these two together and these two together. I think I did it, yeah, I did it wrong. But for high, these two are different circuits, but I'm creating it. It's really dumb how I'm doing it. Either you connect these two together, but besides that. So, low's easier because, so with low, imagine the same bad drawing. With low, you get power from here. It would go to this side. That gets connected, and then power goes there. See how it goes through the whole thing? Instead of splitting off to where this side gets powered, and then this side gets powered. It's kind of a bad drawing, but you get the point. Both powers coming from here. The power has to go through everything to get to the other side. And they use capacitors with this because electricity takes the shortest path or whatever. I don't know. I don't kind of get it, but sorry about the long video, but I know a few people are wondering about these rollabout fans and need help. But let's see, where did I put my switch wire diagram that I came up with? Yeah, whatever, I'll post it later, but there you go. Hope you enjoyed.